Hey students, it's me, Mr. Fitz. That's me in the corner right there if you didn't recognize me. So in this video, hopefully it'll be brief. We have a lot to cover, so it should be about 10 minutes. We're gonna talk about how we created 3D objects from two-dimensional shapes by rotating them continuously about an axis. So for example, we rotated rectangles about this axis here to create a cylinder. We rotated triangles about this axis here to create a cone, and then we actually rotated semicircles about an axis to create a sphere. You could also do it with a full circle. Either way, that works. And so this is what we did. We actually attached them to straws, and then we used my power drill to rotate them really fast, and it creates that image of a 3D shape. And then we also looked at how we take 3D solids and slice them into cross sections and create 2D shapes. So let's take a look. Here we go. We'll look at the very first one here, which should be the triangle, the top one. We're going to look at that one. And you notice that that creates a cone-like shape. And the key is because it's being rotated continuously about that axis, it creates that three-dimensional shape. It's not like what we talked about with rotations earlier, where it was just like a rotation of 180 degrees or a rotation of 90 degrees. This is a continual rotation. So let's look at the next one. That's creating that cylindrical shape. And then the last one should create a sphere. There we go. I even almost color coordinate it to the images we have here. That was not on purpose, but I have the orange one here, the blue one here, and I should have used green, I guess. Anyway, hopefully this helps. We're going to take a look at some examples of some problems that you'll see about this right now. All right, so let's look at these problems here. Hey, it's me again. So first problem here, circle O is centered at the origin in the diagram below. A quarter of a circle, O is graphed. So this graph here represents that fraction of a circle, a quarter of a circle. So which three-dimensional figure is generated when the quarter of a circle is continuously rotated about the y-axis? So the y-axis is this axis here, so we're going to rotate it kind of around that y-axis like that. So what is that going to create? Well, that's going to create a hemisphere. Let's go ahead and circle that right there. So let's look at the next object, next thing here. So which object is formed when right triangle RST shown below is rotated around this leg RS? So if we were spinning this right triangle around this leg here, well, it's just going to create a cone. It's not going to create a pyramid or an isosceles triangle or a right triangle because it's going to be continuously rotated. So that's what that key is. So let's go ahead and circle that one, cone. And then the last one here, if the rectangle below is continuously rotated about side W, which solid figure is formed? So we're rotating it again about this side here, the short side. So it's going to be rotated around this way. So it's going to create that really short and wide cylinder. It kind of looks like a tuna fish can. So that's going to be a cylinder. So let's circle that one. So those are some example problems. Just be really careful read these very carefully. Like, for example, if this question up here said to rotate it about around leg TS, and the key is again around or continuously. TS, if it's going to be rotated that way, then it's going to be kind of this up-down fashion. And then same here, if it's going to be rotated around this side, then it'll be rotated about that way. So let's take a look at some other problems. We're going to take a look at some cross-sections now. So we started our cross-section experiment by we created a bunch of different 3D solids. So you can see some images of them here from our lab. Right, so we created a rectangular prism, a triangular prism, a cylinder, a cone, a pyramid, a regular square pyramid, and a sphere. And then we cut them with fishing lines. So if we cut the the regular pyramid, that square pyramid, directly down the center, actually this is the cone, I'm sorry.
if we cut that cone directly down the center from the vertex, perpendicular to the base, then it creates this triangular cross section right here. And you can see it by looking at that flat object, or if you like put it flat down on the piece of paper and trace it. Then, if you cut that same cone, but more off of the vertex, then you can see it kind of makes this sort of parabolic shape. And that's exactly what happens. It actually creates a parabola. So I can kind of like highlight that right there. So it's going to create a parabola. And then we also sliced up some cylinders and sliced up some other things. Here's an example of the cylinder. So if you cut that cylinder perpendicular to the base and pull it apart just like this, then you're going to see it actually creates a rectangle. So let's look at some more examples. So we talked about using the analogy of a deli slicer. So if we slice up a bunch of meat on a deli slicer, what's it going to look like? So for example, here we have this, and I apologize to all you vegans out there. If I take this cheese and I slice it, and you'll notice it'll have a rectangular side to it. And if I just put it on the slicer, it's going to slice up some nice little rectangles. If I can get it. So here we go. So you can see they're just going to put it right on the slicer, and he's going to slice some rectangles. So that's really the image you need to think about, is that whole slicing of the rectangle off of the rectangular prism. So you can see there, see exactly right there, it's got a rectangular face. So if this were a rectangular prism, that's exactly what it's going to give you. And then here we have this cylindrical, looks like a ham or something, and they're going to slice that. And let's take a look. So they're just slicing off the cross section, and you can see each cross section is just going to create a circle. And actually you can see here are some rectangular pieces of cheese that have been sliced, and that's the cheese that they use to slice it. So there's some images to help us figure that out. And then we're going to take a look at some problems. So here are the problems that we're going to look at. The first one is a right hexagonal prism is shown below. A two-dimensional cross-section that is perpendicular to the base is taken from the prism. So if it's perpendicular to the base, that means it's going to be sliced down this way. So if it's perpendicular to the base, then the two-dimensional cross-section is going to be a rectangle. So if it were parallel to the base, that would be slicing it this way, then it would be a hexagon. But since it's being sliced perpendicular, it's going to be a rectangle. So let's go ahead and circle that. Now imagine if it cut sort of directly off this corner here, right? If we just sliced off this corner, what would that look like? That would actually be, when we talked about that in class, it would look like this triangle. So let's bring in an image for you. Yeah. So this right here, if we look at this, that is going to slice off just a triangle. So if you just slice off the corner of the shape, it's going to bring out just a triangle. Now, what else are we going to look at? Well, let's take a look at this question over here, number 17. William is drawing two pictures of cross-sections of the right circular cone below. Which drawing cannot be the cross-section of a cone? So let's take a look at the cross-sections of a cone. Let me get rid of this image first. And I'm going to bring in the image of the cross-sections of a cone so we can take a look at that. Here we go. So the cross-sections of a cone are going to look something like this, where you have circles, you have ellipses if you cut it on a slant, or you could have a parabola if you cut it on a slant, or what's known as a hyperbola if you have two cones stacked, one on top of each other. You could also have a triangle if you slice right down the center from the vertex. You could have a triangle. So the one that you definitely cannot have is this one. That's the correct answer. So I hope these help. Please let me know if you have any questions. And here is a little fruit ninja to kind of give you a better visual representation of what's going on. So enjoy this, and you can pause the video now if you don't want to watch it. And thanks again for watching, and again, let me know if you have any questions.